Let's get started, students, with chapter 1 physics Icse 10th standard video 3, which talks about equilibrium. What is equilibrium? When a number of forces acting on a body produces no change in its state of rest or motion, the body is said to be in equilibrium. So I have few images from the internet. You can see this. So here both the forces are equal, okay, hence the state is at equilibrium. And in this state you can see both the weights are equal and it is balanced. So we can say that's why it is in the state of equilibrium. So we can see this again. See here the weights are balanced. So hence the state is in the equilibrium. And we have static equilibrium and dynamic equilibrium. So what do you understand by static equilibrium? When a body remains in the state of rest under the influence of the applied forces, the body is in static equilibrium. The example for this is, if a body lying on a table, top is pulled by a force to its left and by an equal force to its right, the body does not move. The reason is that the applied forces are equal and opposite along the same line so that they balance each other. Next is dynamic equilibrium. When a body remains in the state of motion, that it can be translatory or rotatory, under the influence of the applied forces, the body is said to be in dynamic equilibrium. The example for this is, a raindrop reaches the earth with a constant velocity. The weight of the falling drop is balanced by the sum of the buoyant force and force due to friction of the air. Thus, the net force on the drop is 0, so it moves with a constant velocity. Now, we'll try to understand the conditions which it has to satisfy for equilibrium. The resultant of all the forces acting on the body should be equal to 0. The resultant of moment of all the forces acting on the body about the point of rotation should be 0. Next is the principle of moments. What does it say? Principle of moment says that sum of anticlockwise moment is equal to sum of clockwise moment. That is, if the algebraic sum of moments of all the forces acting on the body about the axis of rotation is 0, the body is in equilibrium. That's what the principle of moments states. The next chapter or the topic is the center of gravity. So what is center of gravity? The center of gravity of a body is the point about which the algebraic sum of moments of the weights of all the particles constituting the body is 0. The entire weight of the body can be considered to act at this point, however the body is placed. So example for this, the center of gravity of an uniform wire is at its midpoint, but if the wire is bent into the form of a circle, its center of gravity will then be at the center of the circle. It is not necessary that the center of gravity always be within the material of the body. So it can be outside also. So outside, if it has to be outside, the example is a boomerang. So boomerang center of gravity is outside. So we have some regular objects whose center of gravity, I'll just pick some images from the internet and show you. See here, regular and uniform objects, the geometrical center of some common shapes. So the center of this is here. This is also where the center of gravity and the object's weight, that is W, can be considered to act. Okay, so these are 3 images, and we have few more images. If you want to see, you can see the circle, the center of gravity is here. If it is a triangle, the center of gravity is here. If it is a rectangle, the center of gravity is here. If it is a rhombus, the center of gravity is here. If this is a line, the center of gravity is here. If it is a wire, the center of gravity is here. And if this wire is rotated into circle, the center of gravity changes to this center place. Okay, the cone's center of gravity is 1 by 4 h. Okay, and these are the center of gravities. So example of center of gravity for regular shaped objects. So you can see weight of the card is here. So weight of the triangle is here. Weight of the disc is here. Weight of the ring is here. So if it is an irregular shaped card, optical ping, string, pendulum, bob, wooden block, etc. This is a diagram. Okay, make 2 holes in the lamina. So this is out of syllabus. Okay, but still this is the way you find the center of gravity for the irregular shaped objects. And if it is a plumb line, so center of gravity will be here. So if you have if it is a straight placed and the center of gravity is here, if it is tilted like this, the center of gravity is here. If it is tilted like this, the center of gravity is here. Center of gravity and center of, so these are few examples of center of gravity with respect to the images. Now we will go with uniform circular motion. What is uniform circular motion? When a particle moves with a constant speed in a circular path, its motion is said to be the uniform circular motion. So what happens in this? Direction of velocity at any constant in circular path. And the difference between uniform circular motion and uniform linear motion. So what is it? So in uniform linear motion, the speed and velocity are constant and acceleration is 0. And the uniform linear motion is an unaccelerated motion, while in uniform circular motion the velocity is variable although the speed is uniform, so it is an accelerated motion. Now in uniform circular motion we have 2 forces, like that's centripetal force and centrifugal force. So what is centripetal force and centrifugal force? We'll try to understand. Centrifugal force, a force acting on a body away from the center of the circular path, is called centrifugal force. And for example, if you are you have a string and you tie a stone to it and you are rotating it. The stone is rotating because you are catching the string and rotating it, and the center of gravity is at your hand, and the force which is making it rotate is the centripetal force. Clear? Now few images with respect to uniform circular motion. You can see this. See, this is rotating, and this is also an example. So these are all the images picked up by internet. These are the few images from internet which is showing you uniform circular motion. So when can be an equilibrium? See, when net forces is equal to 0 in case of translational, and net momentum of force is equal to 0 or torque is equal to 0 in rotational. If it is static, it should be at rest, then the net force is equal to 0. If it is dynamic, then it is constant velocity. F is equal to ma, F is equal to 0, acceleration is equal to 0, net force is equal to 0. Then center of gravity is that point of body about which the net moment of force of the weights of all particles constitute the body is 0. Net MOF should be equal to 0, that is the center of gravity. So what are the factors which depend on COG? Is mass, distribution of mass, the shape, size, structure and geometry. So now center of gravity, so center of gravity which lies inside the body can be a circle, and which lies outside the body is a boomerang example. Now next, uniform circular motion. So what is the thing? Here we have speed remains same, that is uniform. Direction of motion changes, hence the velocity changes. Since velocity changes, there is acceleration, and it is centripetal. Next, so what happens is the force is towards the center. Centripetal force is equal to net force towards the center along the radius. You have to keep in mind. The direction changes, and F is equal to ma, that is centripetal force. And so some examples for this are the sun and Earth rotating around the Sun. And one more example is we can take the atomic structure where the nucleus is in the center and electrons are revolving, and the tension of the stone, which I have explained before, when you tie a stone to a thread and rotate it. Giant wheel is one more example of a centripetal force as well as centrifugal force. So if two people are sitting next to each other, A and B, and centrifugal force is what is it? It is not a real force, it is a fake force or imaginary force. So thank you guys. This is what is with respect to first chapter physics.